all we've done so far is we're going to be working with the live live performance capture project that we did for homework, and I've exported out this skeleton by going into Asset Actions, Export, exported as an FBX, then I uploaded into Mixamo and got into a T-pose, and then now I have a T-pose for my character that I can use for the retargeting. So I'm going to minimize this, and we're going to start in Motion Builder. We're not going to be working from Motive because I can't get to work from where I'm at right now. So we'll just show the live link from Motion Builder only. I'm going to bring in the avatar first that I want to work with. So that's in my imports, or actually it's actually in my downloads. I'm going to use that T-pose one since I already have it. And open, and I use mixamo.com, which is the T-pose take, and there's our character. If it wasn't in a, oh, that's actually our data. Let me go back to Mixamo and get the character real quick. So I didn't need the character for importing it back into Unreal, but for Motion Builder I do. So I'll get back to Mixamo. Get our T-pose. I can also not be lazy and just like make it a T-pose inside of Motion Builder, but you know, there's lots of ways of doing it. So this time with skin, because we need to have the mesh match, or we probably don't have to have the mesh match. We could probably just do it with the bones, but it's going to be easier to see it visually this way. So let's go to our downloads, and we'll do this one, which is the one we just got, and this is going to be this is the avatar. And let's start from scratch, new. So avatar's in here. We'll use the Mixamo take. It's in a T-pose, ready to go. We can say the X-ray so we can see the bones underneath. And then let's bring in the motion capture. So this take is 0 frames long, but as soon as we merge in the motion capture take second, it'll actually readjust the timeline so that will be the length of the take. And you see here, here's the name of the take was inside of Motive. So it's loading in, readjusting it, and then if we drag around, we could say, see, here's the dance moves. So, you know, Ryan's doing a pretty good job with the T-pose, and it looks pretty well done. But we can also force it into an absolutely perfect T-pose so it matches our character for just the first frame. Let's go through the process of characterizing. It's something that happens automatically inside of the plugin for Optitrack, but I'll show you how to do it here. So we have our poly guy, and we have to actually tell it, we have to create a new skeletal definition on this, and this is super tedious. Let me go ahead and show you the quicker stuff, which is the Optitrack Skeleton. So here I have Rygai hips and spine and all the kind of stuff for that. I can just select the branches and say 0 out, all rotations. And you see it's just slightly shifted. This is an absolute perfect T-pose, and they'll completely mirror each other. So now they've been zeroed out. That's really great with Optitrack data. You can say that, and by default, zeroed out means T-pose for Optitrack. And again, this is why your retargeting has to be in a T-pose, because the default for Optitrack is a T-pose. Same with Rococo and Accents and Vicon and all that kind of stuff. So I'm not keyframing it. I'm just letting it be a T-pose. So when so I can actually characterize it. And this is when I take a character asset and say characterize the hips, and telling it it's a biped. So it has been characterized, and I know it seems silly that it's called character. Let's rename it to be a character called avatar, so it makes a little more sense for us. And let's deal with the tedious process of getting an Unreal skeleton or a metahuman skeleton to be retargeted in Motion Builder. There isn't really that many resources for this, so this is a good thing for us to play around with because it's not really common knowledge how to go for this. A little bit of trial and error. So we looked at the human IK system when we were doing, let me see where we're at. Yeah, so there's this is similar to the process we were using with Maya human IK system for doing the radical motion stuff. And we're going to select the root for our polyman, and then say define the skeleton, and then we have this human IK skeleton panel. Kind of see if I can give it a little more space. No. Anyway, and there's a few ways of doing it. You basically have to say, this is this traditional human IK thing, and we have hips, and you have spine, and you have all these different names that are the same as they are in Mixamo, but we're going to actually have to make them be the names of these things in Unreal, which for some reason are called things like pelvis and clavicle and all this other kind of stuff. And so we have to basically do a giant from this to that, from this to that. And I find the easiest way to do this is to bring out the a two-pane layout and make this one be an actual schematic view. And the schematic view means that we're just doing it text-based. We're not having to find the thing. We're just having to look at the hierarchy of the nodes. All right. So I'll just go through this, and I'll show you it. And it's tedious, but we'll go through it and do it, and you'll have a recording of it. So the reference is our root. If I double-click it, it's now activated, and then I can select root, and now it's green. So we're going to go through, and we're going to literally do this for all, like, whatever, 25 bones. So hips equals pelvis. And let's go on and do the spine first. So there's spine. So here's the first spine. It's called spine over here, but it's called spine 01 over here. Do that. And then we have multiple spines. So let's just keep on working our way up. All right. And so this is, we're doing this one by one, but what you can do is you can actually save this so you can load it in later on. One thing I think that's actually pretty useful to do is I'm going to actually select all these branches. Hopefully I want to start from scratch. And I'm going to actually add I'm going to prepend a namespace. It makes it easier to save. So it's just basically saying the name UE4 or mannequin or something before all the names, and it makes it easier to save it as XML. So I'm going to apply it to the whole branch. And now you see it says man colon root, man colon pelvis. It makes it just a little easier to save it out. So it might not work anymore. In fact, I'm going to clear all, and we'll do it real quick again. So man root, hips, spine, go in to get the other bones, and then there we go. And then from here, we can look at maybe the neck next. So here's neck and head. So one neck. I always start at the bottom, and then the head. Cool. Let's go down to the legs. That's the next easiest one to do. And it does symmetry mode. I have symmetry mode on right here. So when I do the left legs, it will also do the right legs at the same time. And remember, it's facing us. So this one's the left leg. Even though it's our right, it's left. So left upper is left thigh. This one is the calf. And then let's get into the foot. And then we can get in here to the ball of the foot. And if we go back up, we'll see that it's done both the right and the left side at the same time. Let's go look for the arms. Let's do it with the left again as well. So clavicle is what they're using, and we call it upper shoulder. So let's go into the left side again, left shoulder view, clavicle, do it again. Come on, left. Yes, you're activated, and then I activate you. There we go. And then upper arm, lower arm, and then hand. Cool. So checkbox, it's done. It's actually characterized now. But what's also fun is we have, if we do finger tracking, you would actually have to get here and do the hands as well. So for instance, I would do the thumb, and it shows the right side. Come back. I don't know why it does that. And then the next thumb. matches, and then X thumb. And again, I would shoot myself if I had to do this every time, but once I save this once, we'll be able to use it for all these characters. So this is index, and then index 2. This is why we started off with the fun presentations, so that you guys now are all exhilarated for this part. The middle. And almost done. Cool. This is ring. This is ring 2. Ring 3. And so we're doing just like a straightforward body, but you can see now how you can actually manually retarget to fantastical creatures and say, like, you know, my arm could actually be another creature's tail or something like that. You're saying this bone equals that bone. You can make things be pretty glitchy and funny if you want to. All right, so now everything is done. I'm going to lock it, which makes it a biped. And then if I actually go back to my definition, I can then say, save this. And this is the mannequin, our UE4 mannequin template, which has the prefix of man, which makes it easier to save. And then it tells you where it's saved on your hard drive. So this is just an XML file that you can email or Slack to people so that they can have it as well. Cool. So this is a character named character. And go down to here to my characters, and I can say this one is, oops, I actually made a mistake. This one is not avatar. This one is actually the data. And the one we just made is called avatar. Cool. So let's go ahead and look at the avatar. And like before, it's driven by the character named data. We say activate. And now when I hit play, they're together. All right, the avatar is a little bit taller than, or a little bit different proportions than Ryan, but it's usually pretty locked in with the feet. We can make a couple of retargeting stuff. Let's go ahead and jump into the Unreal though. So we have devices, Unreal, and what character we're going to send out. We're actually sending out the data for the debatable. We can either do the root or the pelvis. Let's do the root for right now. So root, add it in. We need to make sure that Motion Builder is always running what's in the background. So there you go. And then come back up to the Unreal device. And we want to make sure that it's always at 60 Hertz. And let's make it active. Cool. So come back over here to this project. We need to make sure that Live Link is the plugin is working, and it should already be working. And we should see that we have Motion Builder, and it's bringing over the man camera animation. And then, because we know the Rococo data, we couldn't go this far, but maybe you made an animation blueprint. You have the animation blueprint from the skeletal asset, ABP. This is called Polyman. And then it's just called Live Link Pose. And then we're going to use our T-pose to start off with, because we need to make sure that it's by default a T-pose. All right, so essentially we're adding live link data to this actually, not to the A pose. I'll plug it in here, and then choose man, compile. All right, got one frame of it. Are you not in real time? Let's take off the T-pose and just see if it's still working. Man, live link. It's live. It's running. Oh, you're not playing because you're not on loop mode. There we go. Cool. So there's the connection coming straight from Motion Builder without Optitrack. Everything looks pretty good. Not much is happening with the hands. There's not like individual articulated fingers, so we're not really seeing all their effort there. But it's good enough. Cool. So our homework is to kind of like we did with our collaborative template, is to work in our level that you might have already made, and to do some at least one interaction via live show control with some asset you've created or found for the final project. I'm going to move this template over to our shared project so that we have it and you can see what I'm doing with this character. So let me go ahead and take this character, this whole folder, let's start here, and I'm going to migrate this. All right, so there's everything that's a dependent of it. We have the materials, we have the physics assets, skeleton, the animation, and we're ready to go. I'll find our project that we have together, which is fall. No, this one right here. And then it says find the destination content folder. So I'm being the first person to migrate my content over for the final project. And we're done here. We'll keep this running. I'll just minimize it to get out of the way. And let's open up the other project and get going. New projects. Cool. Again, I think we were at revision 45. So I'm now working in our live shared project for the rest of this demo, and you guys can see all my work, right? You can download this and you can deconstruct what I've done. Okay, great. Let's go find that guy. He's in his own folder called Live Link Performance Capture. And there it is in all its glory. Cool. Let's bring in the T-pose and then bring in the live link. Cool. Oh, I guess it doesn't like the T-pose in front of it. Let's try that again. Let's try T-pose. Yeah, okay, that's what it should be. I wonder why it was paused. Maybe I can't minimize Motion Builder. I have to keep it open, but in the background. All right. So we've already been working in our assets folder, and I have a map called level Todd. So I'm going to go ahead and throw the stuff I'm doing today in here. In the homework, you were supposed to make a blueprint of your polyman, and I'll kind of go through that process. But everything was in the construction script. We're going to make ours in the actually event graph, because we're going to drive these changes in real time. I'm going to create, actually let me keep it kind of separated. I'm going to put this into Live Link Assets, and I'll make a blueprint called BP Polyman, just a regular actor blueprint. And again, if you've done the homework, you've already done this, so this is not new territory for you. And if I have the skeleton selected, it's context sensitive, and it'll, if I add a skeletal component, it'll go ahead and bring in that man. And then we're going to bring in the animation blueprint called ABP Polyman. And there it's going. Dancing around. This is my level from before. It really doesn't have much in there. I might go ahead and add in a like some sort of environment. Let's actually do let's do unlit for a second. bring in the blueprint of Polyman. And you see when I move it around, it's animating, but it's not actually animating right now. You can actually add in this little component called Live Link Skeleton, and it'll make it always animate. It's a lot more fun for the people who are mocap performers because they're always moving. So Live Link Skeleton, and now it's always playing. Cool. And so in the homework, it was using the construction script, which is like the the setup script. We're going to make things dynamically change in the event graph. To kind of go over the homework again, the Polyman has a material, and this material is an instance that has two colors that can be driven at real time, and all these other values. We're just going to do maybe color 1 for right now. Color 1 is like the inside color, right? And we did this before for the midterm, so I'm just going to kind of do it again. So bring a reference to the Polyman, and then we're going to create a dynamic material instance. This is, and then we have to reference that instance, which is mi material instance Polyman instance. So mi Polyman instance. Element 0. This character only has one material ID, and so it's only addressing 0. If it had multiple material IDs, you might have to make this element 0, 1, or 2, or 3 to address the exact material slot that it goes into. And then on event begin play, we're going to create this dynamic material instance. And what does that mean? It means it's a material instance that can be run at real time. It is dynamic. We're allocating resources to drive parameters in real time. The construction script version that you did for the homework didn't actually require that because you're only changing the parameters before you hit play. But because we're hitting play, we need to like reserve resources for running in real time. So I'm going to save that as, I'm going to store that as a variable, and we're going to do this a couple times today, storing things as variables so that they can be addressed, or they can be, you can grab references to them. So I'm going to call this, it's a dynamic material instance, so we'll call it DMI Polyman. Oops. DMI underscore Polyman. And how did I create that variable? All I did was say right click and promote to variable. And we'll do this a few times this way. So now, if I wanted to, I can grab reference to this in my sequencer, or I can do it in real time using live show control. All right, so let's take a look at how we're going to be doing live show control today. And then if I want to change the color, I would say grab a reference to this this dynamic material instance and say set scalar parameter value, and then the value could be color 1. I actually need to look at see how if they did it with spaces or not. So yes, they did it with spaces. I wouldn't ever recommend doing it that way, but I just want to make sure I'm not making any human errors. This parameter is actually called color 1. Copy and paste it, and then I can change values of either the scalar, but actually it's the color, so it actually needs to be a set vector parameter value. Set vector parameter value, and it's actually this one, color 1. This blue pin is just a color wheel. All right, it's called a linear color. It's just a 4-value thing, which is called a vector. It is an array of an RGMB. We could say make linear color or make color. And then you can see it's actually an RG and a B, right? And then at runtime, I can maybe make this some random colors or whatever. But what I want to do is I want to be able to drive this dynamically using show control. All right. So it's time for us to move over, and before we start doing any more in Unreal, it's time to introduce the idea of OSC. And Grant was talking about this. This is open sound control. We've mentioned as well when I talked about why we're creating this VPN, so we can send these values to each other, is Open Sound Control is a way of sending a UDP messaging between our computers to a rendering computer to change values in real time. It was actually invented to replace MIDI, and it was supposed to be used for music, but it ends up being used a lot more for video, and it's how you do all your VJing and everything. It's via this really lightweight internet protocol that, again, because we VPN, we can send to each other and we can drive in real time in remote locations. So I would like everyone to go to cycling74.com, and I will put this in. I'll make a new link in Slack. Where's our Slack attack? Slack, and let's make a week 12. Show control OSC. Again, OSC is Open Sound Control. I am going to add in a link to Cycling74. This is the company that makes Max MSP. You can download Max for free. That gives you a 30-day trial, which will last you for the rest of the semester. You also don't have to start your trial if you're not planning on saving it. So we're going to find, let's see, where do you download Max now? They just changed the layout. Download. So Mac and Windows, you can download. It'll, you know, I'm on Windows, so it's giving me Windows 64-bit. If you're on Mac, do Mac 64-bit. It's about 500 megabytes. Go ahead and download and install it now. Let's go ahead and make sure that we're all ready to go. So this is what our homework is going to be involving. You can also use Touch Designer. You can use P5. You can do other stuff, but Max is probably the quickest to get up and running. It's also the director of our department, Luc Dubois, is on the development team for Max, so it's kind of like our house style. So I actually did my thesis in Max, and its graphics rendering pipeline called Jitter, which actually Luc was on the team that developed. So I already have it installed, and let's take a look at Max really quick. And you're saying, whoa, Todd, you're going to introduce new software when we have 3 weeks left of class. We're not going to go super deep into it. It's just really cool because it has a graphical user interface. It has like icons that are really easy to manipulate, like sliders and knobs and buttons and toggles. And that's what we're really going to get into. So again, if you've already used the trial, like, you don't have to save. I'm going to give you the Max patch for homework. You don't have to do any Max development for this class. You know, if you want me to make anything for you, I have licenses on my computer. We have licenses on the show control computers. So if you want to make any edits, it's fine. But I think a student license, they do monthly student licenses, which are fairly cheap as well. If you're IDM, you could probably get a free license through Elton Kwok, who's our technical director. I'm going to create a new patcher. And of course, super intimidating, just a blank canvas, right? For software, this is pretty sparse. But we're going to kind of take a look at some of these UI elements on top. All right. So first you have objects. So just drag it down there. So in here, I would type the name of an object. All right. We have messages. These are ways of looking at sending messages to these objects or receiving messages from these objects. Don't need to comment. Toggles. Toggles are great. Right? Toggles turn things off and on. And again, everything can be resized. We have buttons. Totally great. We're going to use buttons. And if you see as a highlight over, it has little shortcuts. Button is B, toggle is T. Let's get into numbers. We have two different kind of numbers we're going to use. We have index numbers, right? We have 1, 2, 3, 4, 5. And then we also have floating point numbers, which are decimal points. What else is cool? Sliders. You got to have sliders, right? Slider is a vertical slider. If I resize it, it's now a horizontal slider. That's pretty cool. And then we want a knob. Oops. A knob. Cool. So here's this little knob. And so as you notice, if I click on things and move them around, they're moving with me. But if I lock it, I think you can also right-click and say take off edit, turn on and off edit, and I think also control clicking locks and unlocks it. Once it's locked, I can actually manipulate the slider, right? So I now have a way of sending data. this can all be very easily hooked up to your MIDI controllers and be very, like it's one thing to have a mouse, but if you have a MIDI controller, you can use all 5 of your fingers to drive things in real time, just like a piano. And in fact, there is a piano in here if you want to use that. Where's that one? Yeah, they even have a piano if you want to connect it to your MIDI piano at home. So what are these things doing? I'm going to use this little message box to preview in some of the values. Here's a toggle. If I put it in the back side of it, which is just like it's blue, it's this cold inlet. It's not actually sending data. It's just reading a message. See, it's sending 1s and 0s, right? From this bang, we're sending the word bang, right? Then from the index buttons, here again, I'm locking it. You see we have whole numbers. And then from the float numbers, depending on how far away from the decimal point, I can actually do like just the index numbers. I could do the tenths, hundredths, thousandths. You can really make it big and get out there and really drive fine numbers. And we want to send this data to Unreal. So OSC was actually kind of invented for Macs, and it has a native implementation of sending UDP. So we're going to actually say use one of these new nodes, right? It's End button, or you grab from up here, new object, and say UDP. And you'll see right here that it gives me, it autocompletes and says either send or receive. I'm just going to send. All right, so I'm going to hit tab, and then hit spacebar, and it tells me what I need to do. I need to figure out my IP address and my port. I'm sending it locally. I'm not sending it through our VPN, so for right now, our local host is either called localhost, or it can also, that's the actual IP address for localhost is 127.0.0.1. And then we need to do a port. Again, it doesn't really matter what your port is. In general, creative coding uses ports between 6,000 and 9,000. Max uses 7474 because it's by the company, Cycling 74. We're going to use 8,000, which is fairly standard for doing Unreal, right? So now we can send all this data to Unreal. But how do we keep it separated? How do we structure the data so that we can parse it on the Unreal side? And as I said before, this is UDP is a internet protocol, and you quite literally send it on internet addresses, and like a URL has forward slashes. So I would want to prepend some sort of address to this before I sent it out, so that I could parse it on the Unreal side. So this toggle, I would want to maybe say new, and I want to prepend the word toggle to it with the forward slash. And then I can get my little console log out here, and then I'll use a print object. And again, I'm showing you Max, but I'm actually going to give you this, so you really actually don't have to do any Max. I just want you to see it. Just want you to show how I'm making it. So you see I'm printing out /toggle 0 and 1. So I can then grab that URL in Unreal and parse out toggle data over the toggle address. Bang, we just want to send the data for a bang. So I'm going to say, I'm going to make a new message object, which is right here. And I want to just send the message bang, /bang. Cool. Then integer, I can maybe say a new prepend /integer. And then I know with the float data, we're probably going to send like a value for glowing. So let me say, and then I can resize this canvas any way I want to. So I can say new prepend, let's just call it glow for right now because we're going to make something glow. We can take the slider, and if we look at the data from the slider, we can see that it's actually sending out MIDI values from 0 to 127. and maybe we want to be like adjusting our lights, and lights can get the numbers like 10,000. So we're going to scale the data. Let's do a new object called scale, and say from 0 to 127, but we want it to actually be from 0 to 10,000. Right, so we've scaled the values of 0 to 127 from to 0 to 10,000. And there's all these little buttons on top where you can actually live manipulate each of these values if you wanted to calibrate it in real time, which is why Max is super cool to prototype with, is because we don't have to compile it. And while Unreal can be compiled, we can be adjusting all these settings, and hopefully we'll get a chance to see that. So if I were to add the print button to here, I'm holding down Alt to select the wire, delete it. So delete it, there we go. Now I would say that even though my slider was sending values from 0 to 127, it's actually now doing from 0 to 10,000, right? Just scaling the range. That's a cool one. We can also see the knob does the same thing. Right, so two different ways of doing it. And again, these can be easily mapped to your MIDI device. One other cool thing I like to do is grab audio. So if I do a new object for a analog to digital converter, you might see that this looks like a microphone. And if I turn it on, I can actually get my microphone from my computer. So there's a specific object you don't really know about, but I'll go ahead and put it out there. Looking for the peak amplitude. It has a little tilde on it because it's a sound-based object, and I'm going to look every 33 milliseconds for it. So like 30 frames per second. I want to look at my amplitude, and let's see what this data looks like. So we can see as I get louder, the number goes from 0 to like 0.7. Right, so I'm now getting audio reactive data. There's a cool thing called a multi-slider that I can now go to my inspector and change what it looks like. It is going to be a line scroll from 0 to 1, because as we said the values are. Instead from -1 to 1, we want to be 0 to 1, which we might scale later on. And now we can see that my data is being live manipulated. Cool. So now we're getting audio reactive values inside of Max. Usually when you VJ, you want something to happen really quick, but you want the fall off to be slow so that you get a little bit of a drag on it. That's a cool object called slide. So we're going to say new slide from 1 millisecond for onset to maybe 10 milliseconds for decay. And so now we see that as I talk, it hits immediately, but then it slowly drags off. And that's usually what you want to kind of have for audio reactive, so that it's not so chaotic. It has like a little bit of, you can actually see the values for a brief period of time. And then we're going to use a system of sends and receives so that we can send everything to UDP send without having to drag a bunch of wires. We're going to make a new object that's going to receive data, and I'm just going to call it UDP, and as long as everything is sent on UDP, it should all match. So I'll move our print down here, and we can see all the data being received. And then we're going to take receive, I'm holding down Alt and clicking, and it makes it copy, and I can say send. Oops, send UDP. So now, oops. No, there's no, right now I have an audio in, there's no audio out. We could definitely make an audio out if we want to, but I don't care about hearing my own audio. I only care about generating values. You guys are hearing a buzzing noise? Okay. Let's see. Okay. Let us turn off audio for now. Is this better now? Okay, so we've proven audio reactive. What we're going to do is just use sliders and knobs for now. This wouldn't be, this hasn't been an issue. Maybe it's something with my graphics, my audio card. I was actually having issues with my headphones earlier, so maybe I've done something to my my computer. So maybe it was that first day I used the computer and we had that faulty HDMI and everything's been screwed since then. So anyway, you saw that that's how you do audio reactive. We'll use sliders and knobs, which is fine. And I actually didn't prepend any data on this anyway, so let's just bring over our this guy, and I'll leave it hooked up so you can have it. We'll do from, so this is a new scalar. We're going to make this scale from 0 to 127 to 0 to 1. So it's sending the same values as our audio was. There you go. Got a little smoothing to it, and then we'll prepend the internet address audio. And again, that's a mistake. That shouldn't have been there. Cool. So we have this data. Let's move these over. Let's do a little organization. All right, so these guys are together. That's our audio. This is just looking at integer values. This is showing some, what we'll say is a glow value. And then we're going to have a toggle and a bang. And let's add in a bunch of these send UDPs so they can all go where they need to go. Send UDP, send UDP, send UDP, send UDP. So that all these little sends are sending it kind of invisibly to this receive. And I want to add in one other thing. It's called a panel. It's called a panel picker. No, it's not called a panel. It's called a picker. New picker. No. What was it? It was called. That's a color picker. It's called a new. Actually, what we'll do is swatch. So this is another cool object right here called swatch, and it actually generates an RG and a B value as well. All right, so these are three values side by side from 0 to 1 for RG and B. We're going to unjoin them, new unjoin 3, so we can separate them out. There, we got nothing but space. Let's keep on going. And then now we have the R, the G, and the B. We're going to new prepend red. Prepend green. And then prepend blue. Shunk. Shunk. And then all of these can also be sent to UDP. So we can always come back and mess around with Max, but this is pretty much all the different things I want to take a look at. Right, I've locked it, and I'll save it, and then later on in the class, I will I'll send it to you so you guys can have it for later on, and you don't have to edit it if you don't need to. All right, I'll do it to my desktop, and it'll be called class 12. Cool. So let's go back to our Unreal project. And yes, save all just in case. And OSC has a native implementation in Unreal for the past 3 engine versions. OSC, and it's already been enabled. All right, so open sound control, and we're going to receive OSC. Now, there used to be a plugin from like Unreal Engine 4.6 and on that I've always used, and I find it much easier to teach, but it's not what you can actually use in a production. It's really simple to utilize, but it creates basically every time you drag in OSC, it creates a new server inside of Unreal, and things get really complicated pretty quickly. And you really want to bring in Unreal in just one server and then spread it throughout the Unreal Engine. And this is kind of like something I developed and I've shared with some other projects, and it's kind of been the way we've been running big projects. I'm going to show you how I set it up. I'm not expecting you to do this or understand this for this class, but you can have it from me, and then you can always copy and paste it and use it for your project in the future. But I'll teach you how to utilize what I'm going to set you up. So I'm going to kind of be your guys' technical director and show you how to use Unreal kind of in the more enterprise use case and create a system for sending data throughout to all of our blueprints or all of our assets, okay? So the first place to start is Unreal Engine OSC. And there's the documentation for the plugin. And I will put this in our Slack for week 12. Cool. And what's great about this is that it has some examples for how to use OSC. And these and blueprints, which we haven't got into, are actually, you can copy and paste blueprints and send them to each other via XML. So we want to be able to find, we're not really sending OSC from Unreal, we're just receiving it. We want to be able to receive all messages that come in here. So I say copy node graph, I say right click and copy, and then I'm going to create a new blueprint. And it's going to be, let's do it in assets, blueprints, and we'll make a new folder, or I can make a new folder for OSC if I wanted to, but I'll just do it here in this root, and we'll call it BP, oops, I didn't mean to do a folder. Blueprint class, and I'll call this one BP OSC. All right, and eventually it's going to have to work inside the level, so I'll go ahead and bring it inside the level. And now everything that would come from OSC would be available for this level. Let's go ahead and let's open it up. So nice little blank slate. I don't need this one. I'll use this one later on. So basically, this is event begin play and event tick. This is like your void setup or your begin play, and this is your draw. This is what happens every frame. We're going to hook everything up to begin play, and we have OSC receiver. For right now, for this week's homework, we're going to be just testing it locally. So as we've already explained, that is 127.0.0.1, oops, .1. And then we've established that the port, we're going to use 8,000 because we're already using 7,000 for multi-user editing, and I'm going to keep it 8,000. There we go. So what happens is when we hit play, a server is established. It then binds this event that's receiving OSC data. It grabs the message addresses. It converts it to text so that we have it as a string, and then we can get integer data. We can also get OSC float data. Oops, I'm going to spell float. OSC float data. I agree with both of those. And then it can print it out for us. Let me put in this one instead, and we'll prove that it works. We need to be able to get the OSC data here. So that's us manipulating it, getting both indexes and floats for right now. And let's see what else we got. So kind of like we did with the dynamic material instance, I do like to store these as variables. So I'm going to promote this to a variable and just call it OSC server. It's just something that that works. If you hold on Alt, it gets rid of all connections. There we go. And I'm going to call this one OSC server. All right. So with this in the world, if I hit play, or for this, it actually kind of might be, if we have cameras and stuff, it might be easier just to hit simulate so it doesn't really move. And I come back over to Max. We should see, yeah. So we're getting values on the channel audio. We're getting values on the channel integer. We're getting glow. We're getting toggles. We're getting bangs. Color. Let's see, that one's not coming through. Let's go back to our messages. Oh, because it's not coming from the color patch. It's coming from this message box. Yep, you move. Oh my goodness. You're tiny. Let's just delete it. And there we go. So now we're getting colors. There we go. So yeah, all our data is coming through to Unreal. So let's harness it and do something with it. Save again and hit stop. Okay, so this blueprint is getting the data, but now we want to send the data to all of the different places inside of Unreal Engine. And this is kind of like the only complicated, because we're copying and pasting this and giving this to you. This is the homework. This is the only complicated concept because we don't do much blueprinting in this class. But the idea is that we want to create this tunnel that goes from our blueprint to any other blueprint inside of the game engine. And that's a special kind of blueprint called a blueprint interface. All right, that's a way of passing on these events and also passing on data with these events. They kind of introduced it in really started using it when VR hit, and it's been very, very useful for connecting VR interactive objects and making sure that your hands can do things and your helmet can do things with everything. So I'm going to show you blueprint interfaces. Right click, and now I'm going to go down to a section called Blueprints and Blueprint Interfaces. So there's a new kind of blueprint. I prepinned it with the word BPI, and then we'll call this one Final. So this is BPI. This is the blueprint interface for our final project. You can make many interfaces. I only make one. And then all these different functions over here are events that you can call and send data with. And so we had things like audio and integer and glow and what are some other ones we had? Toggle and bang. And then we also had red, green, and blue. Cool. And so these are all, these are like, we're creating these little portals, these little tunnels that will go from our OSC blueprint to any other blueprint we might create. Right now, we don't have any inputs or outputs, but we do want to be able to pass these values through. So for audio, it was a float, right? We're sending from 0 to 1. So let's choose the data type of float, and we'll call this, I think I can just call audio again. All right, so that's the audio float. Here is the integer float. So if you did the homework, you might have seen where you have the thing attached to the performer's hand, and it changed different primitives, and you had from 0 to 1 to 2. So we can pass through 0 to 1 to 2 and change those things in its hand. So that's an integer that we're passing through. So that's just called integer. And then for glow, that was a float. right? At a decimal point. For toggle is actually a 1 or a 0, which could be considered a Boolean. We're going to send it as integers, keep things simple, and make it the 1 and 0. So that is the toggle. All right. The bang we don't really need to send anything. It's just being triggered, so it doesn't really need any data. And then these are floats again. So we have red, green, and blue. Let's make sure it works. Blue. All right, so we've now created our interface. Let's take a quick look and see if I got all the data types. Bangs, toggles, glows, integers, audios, and colors. Okay, so that's everything we need. And let's go back to OSC. All right. One thing we might notice that if I hit play and I start playing around with Max for a while, you'll notice that the actual server stops working after a while. This is like kind of a known bug in the community. So I'm not going to play with it long enough to make it. Basically, there's like a garbage collection issue, and the OSC server shuts down. And since we're going to be doing this for like hours at a time, I'm going to show you a quick way to trick that. Again, I'm creating it so you can copy paste it later on. But essentially, sometimes this server isn't valid anymore. So what we want to do is every single frame, we want to check and see if the server is valid. So I'm going to grab a reference to it and say, is this valid? Has it been destroyed from garbage collection? So check every single frame to see if it's valid. And if it's ever not valid, we want to create a new server, and so that it reopens it up. And we only want it to happen once. So I'm going to say do once. So if the server is ever not valid, go ahead and create it again. Cool. And then once you've created the server from scratch, then we can reset this do once so they can do it once again or later on. Cool. And then we might want to know when there is a reset. We might want to know when the server does break, so we can always maybe print that we had to create a new server, just in case it's important. New server created, and that'll print to the screen. Cool. If you don't like how this is all organized, you always double click on your little wires and move them around, organize them how you want to make it look nice. I tend to make messes. All right. And so the OSC server is super robust, but I really don't care about printing out the values. I want to send the values on our Blueprint interface. All right, and we have values of both floats, and we have values of both floats and integers. Sorry, but we don't want to send it everywhere in the computer. That's going to be completely way too heavy. We want to send it on only with things that are using our Blueprint interfaces. So we're going to say get all actors with interface. So as we add these interfaces to our blueprints, which I'll show you in just a second, it'll only send the data to the actors with the interface called BPI final. So once we have all this data, let's send it out to BPI final, and let's store these all these actors. All right, so here's all the actors with BPI interface. And let's send the data out. And again, I'm making this, you don't have to make this, it'll just work for you. So we want to send values of floats and integers to these interface objects. Let me compile and save, that way we grab reference to them. And let's look for, first of all, we had audio was one of them. Go up to the very top, you'll see a, maybe audio wasn't the best one because, okay, we want to look at the class BPI final, and we want to send a message to audio. if it's the correct one, it'll have a little envelope here. It's sending it out, and it's we're gonna go over here, and oh, I'm doing it wrong. We need to choose which address we're sending it on. We have to send this path out. So here's a new object. You might have seen this if you've done Arduino stuff. We're going to say switch on string. And this is a elaborate node that lets us parse all the data that we have. This node says we don't need a default pin, but what we do need are all the things we're making. We have audio, we have integer, we have glow, we've got red and green and blue and what else do we got? Red, green, blue, integer, audio, glow, bang, and toggle. So here's how we're parsing out those addresses. Pile. Great. Here they all are. So connect audio to the audio. The target is anything with the interface, and the data is a float. All right. Let's look up integer. And it's going to be a message. Let's see. Let's see if we go for BPI final. Okay, there we go. So if we look at BPI final, we've got integer, BPI final. We've got, what's next? Glow. Let's make these a little organized. And then you have red, green, blue, BPI final, red, BPI final, green, BPI final, blue, bang and toggle, that's the wrong one. Oh no, that's fine. Yeah, because it doesn't have any message. It's just triggering things, and then VPI toggle. Cool. Let's connect the execution pins. So integer goes to integer, glow, glow, red. Missed it. Red, green, blue, bang, toggle, and then when you give it the data types, so let's just, what we could do is cheat a little bit, create this little node here, and then feed from the node to glow, to red, to green, blue, and then integer. Drag it out for integer. Cool. So now I've set everyone up for success. At least I thought I had, until I forgot that I hadn't done this. All right, let's see if we get rid of those errors. Yay. All right, so we're sending all this data, and they're going into the interface. The interface can be brought into any blueprint. All you have to do is make sure this BP OSC is in your level, and then it can send all these values over here. Let's bring in a cube, zero it out, make it big. Drag it underneath. So we got a little floor. And let's bring in some lights so we can actually see what's going on. Let's do lights, and we'll add in like another spotlight. And let's make it so we're lit. Cool. All right, so let's start doing some OSC. We obviously have our character, and that's probably a good place to start. We know we can drive the color of the green of our character, so let's open up the Polyman. And to make the blueprint interface available to us, we need to go up to the class settings. And so this will be the homework. Like the homework is to make a blueprint, and then go up to your class settings, and add the interface. Once you add BPI final and compile, all that data is available for this blueprint now. And if we want to drive color 1, we would say, give me the event for red. Right? So here they all are. So we say event red, and it has execution pen, and it has the R for the R. All right. Let's do event blue. And then event green. Compile. Now if I hit play, I see that green color. We're moving in real time, which is super cool. Right? And again, right now I'm looking at localhost. I could change this to our VPN, and then every one of you guys could take this max patch and fight over what you want to drive in real time inside of our game engine, right? And again, we can have our audio signal driving these RGB values, so as we clap and pop and whatever, we're changing colors in real time. Okay? So here's the guy right here. So instead of doing it as a construction script, we're doing it live as dynamic stuff. Okay? Let's scale back a little bit and do something from scratch. Similar thing altogether. I have this light right here. Let me, I can convert it to a blueprint if I wanted to. I'd say convert this to a blueprint, harvest all the components of just making it a regular actor blueprint, and say sure. So now I have this blueprint that has the spotlight in there, right? It's still everything is the same as it was before. It's just now is in a blueprint that's magenta. Maybe I want to change this color as well. So what's the first thing we do? We have to add the interface. So class settings, let's add BPI final, and now when I compile, I can grab a reference again to the event red, green, and blue. All right? So let's just like steal that. Copy, paste. If the interface wasn't there, this would give you an error. It's ready to go. And what do we want to do? Well, literally when I drag off this light component and this context-sensitive box is checked, every single function inside the game engine that can happen to the light component is available to us. I know I want to change the color, so let's do color. All right, so I don't want to get it. I want to set the light color though. So I want to color. I want to set light color. Cool, and that just plugs into there. So now I hit compile, and I hit this again, bring up max. Doesn't seem to be changing the colors. Take a look at that. I might need to do it from scratch. Let's see. So what's cool about this whole OSC thing is you can kind of you can see it jamming out, right? You can see when it's driving itself. And so that's a quick way to debug this, see what's working. So it's not working. Let me hit stop. Oh, because I haven't executed it, right? It needs to actually execute these functions. Cool. So let's try that again. All right. So the color's changing. All right. So now it's red, and now it's blue. All right. So that's all matching. We have colors. So that's cool. Maybe we want to take a look at the glow or something. Let's, or actually what we'll do is we'll look at a visibility. We'll toggle the visibility of this character. Let's go back into our polyman and not that, nor that. We don't need our OSC anymore. We don't need our interface. We do need polyman. So what I want to do now is toggle the visibility of polyman. So I will come over here and grab a reference to him. And what we want to do is I want to do visibility. So visibility. And we can see I have set visibility or toggle visibility. I'll do set. I'll bring a reference to toggle, event toggle. And then I'll execute it. And then this integer, the 0 or 1, will turn into a Boolean. It can convert it automatically to being off and on. And then propagate to children as if it has anything attached to it. I mean, everything attached to it, like if it has fire attached to its hand, the fire would also set visibility. All right. So let's now hit play again. And let's do the toggle. All right. So now the guy's disappearing off and on. All right. You can also just make this a spawn. You can spawn new characters. I'm just talking the visibility for right now. Let's do one more thing. Let's go back into this character and let's take a look at the material. It doesn't have an emissive color. Nah, I don't want to do it that way. Let's do it with another object altogether. So just so we have more experience making it from scratch, I have let's go back to light. Light, I want to set the color intensity, right? So everything that's in these detail panels has a function that could be driven by OSC. Just like it could be added to sequencer, but I want to set the intensity here. So let's do, take a reference to this light and say set intensity. There it is. And then I'm going to use audio, right? It would, if my audio was working, it'd be an audio reactive light. Plug it in, audio. And so, actually I don't want to do audio, I want to do glow. Because that's already scaled correctly from 0 to 10,000. So we're going to say event glow. Cool. Compile, save, and then again another proof of that it's working. Go back to max, and then this is the one, right? So turning off and on the light, right? So if it was audio reactive, it would be like that, right? And then we can change the colors, and if this was all on MIDI, we would be manipulating multiple things at one time, right? So why is this useful for us? Oh, and then bang. You know, bang is just like particle systems or whatever. Like if you want to do a one-shot, these are also called momentaries or cues. Momentaries are when you say on, as long as I'm pressing the button and then when I let go, it goes off. A cue is just a one-shot. I don't know if I have any particle systems in here. We're already running out of time, so I don't want to go too much further without getting to the actual point of this whole thing, which is this all works in Take Recorder. So, Take Recorder, what do we want to work with? We want to look at the polyman, and we want to look at the spotlight blueprint. And let's make this a little bit more angled. There we go. So I can actually pilot this so I can aim it correctly. There we go. All right, so let's do it in Take Recorder. Take Recorder has a lot of settings. I like to do things at 30 frames per second. Let's see, what else do we want to do? Okay, so what it says right here is that there's 15 properties and 3 components, right? Polyman has a scene root and it has a skeletal mesh. The spotlight has one component, which is just the light mesh. We won't really get into too much detail, but basically I can either I can possess these models and make it so I'm just animating the models that are here, or the parameters that are here, or I can make it so I'm recording everything as spawnable, and that way my sequencer can go into any map and automatically spawns my character, which might be useful for doing characters. You can choose it on a per asset basis. The issue is that when you're doing playback, you'll then see two of every model, which can get kind of confusing. So by default, I'm going to make both of them possessable. And it's just one of those things where the more you work with it, the more you realize, do you need it to be just taking over these assets, or do you want to spawn a new version of the assets? And then if we really want to get into the details, we can see that there's all these properties are being animated. We really don't need to animate every property from the polyman, right? We're just looking at maybe visibility, and we're just looking at, what are some other ones? Oh, we're looking at the color. The color we'll come to in a second, all right? So I can maybe turn all these off and just record visibility. If I want to save resources, it really doesn't matter. I just turn them all on for right now. Let's see, what else do we want to make sure? We want to, so we did possessable, and then I want to go into the main settings, and I don't want to go into subsequences. It's nice, it keeps everything compartmentalized, but I want to just make everything right there in the sequencer for me. I don't need timecode for right now, and we don't want it to be there. Okay, so if we're recording a ton of things, if like 15 people have live objects that are in our scene, we can save a preset. So we can say this is, you know, a preset for scene 1. So let's just make a folder for presets. And our test scene, so in case it crashes or we come back and re-record a scene, if we load up this preset, it'll bring in all these settings we just saved, all these assets, and all the settings will be saved here. And that makes it easier. And then let's go over here, and there's no sequencer. We're going to hit play. I think it'd be fine just to do it in simulate mode. All right. And then let's hit record. And come over here. And we got glow intensity, we got color changes, we got toggles, right? Do I do anything with audio? No, I didn't do anything with audio, and I have nothing with bangs. But that's the idea, is we have red, green, and blue on the color, and then we have glow and toggles. Okay, let's go ahead and stop. Stop again, and then let's preview that take. Oh, it did the subtracts. I said no subtracts. Oh, because I clicked it. Anyway, you can see that it's recorded some of these values. It's recorded the color. It's recorded the toggling of the character. Did it? Let's do one more take and make sure we're doing it not to subscenes. That way it's easier for us to see. And let's do it in play mode this time, see if that's any different. All right, record. All right, glow. That's an interesting effect that's happening. I have no idea what's going on there. There we go, and toggle, toggle off, toggle on, toggle off, toggle on, off, on, and then stop, and then stop, and then let's review the take. Cool, and now you can see my keyframes here, right? Oh, and the reason why the guy wasn't disappearing is because all my game objects are here. If I hit G, it hides game objects, and now you can see that the character toggles off and on, everything changes color, right? So one thing we honestly can't see because the character is right here, again, everything can be animated, everything can be edited, is that our character is actually still green. So here's the one thing that I figured out last night for this stuff. Come back here. Get back in your light. So if I look at, go deeper into these settings, we can see that these default tracks, a lot of components, it already records things like of our light. It automatically records intensity and color. right? Intensity is right there, color are right there. These are just things that are automatically recorded, but material changes don't actually happen to the character or to any of our assets, right? They are not they're not stored automatically. And I was trying to figure out how to custom add things, and I found this cool little secret, or not secret. I found this cool workaround, or let's just call it a hack. I found this hack to make it work for material changes. So we're going to go back into Polyman, and kind of like what we were doing with other items, we're going to store these values as variables. So if I just promote to a variable, can I do it this way? No, we'll do it this way. Just promote to a variable, reconnect it. Screen, and do this one. So now, if I select these variables, I could say expose to cinematics, expose to cinematics, pile, save. When you add something new, you actually have to replace the object. So I'm going to go back in here, delete it, and add it back in. And now there are these values are now are tracks that are being recorded. Okay, I'm not done yet. This is just the beginning of the workaround. All right, so let's hit play. Let's hit record, and we'll get to RG and that B. Right, it's there when I'm doing it live, but it wasn't recording at the sequencer. Hit stop. Stop. And the workaround for this is to go back and look at the take, to unlock it, or sorry, unlock it here. And then as a scrub, it's not changing the color. And see, this is the thing where when I threw it back in, I didn't make it possessable. It's spawnable, so it made a separate copy. All right, so characters is kind of fun because then you can like perform with yourself. But sometimes you don't want to have two objects. Like if you have two lights, they're going to get in the way of things. You can't actually analyze your lights. So now you want to possess lights, but you want to spawn characters, and I'll kind of guide us through this whole process. All right. So there's the mocap that's being recorded. But what I want to do is, so now it's stored these values on red, green, and blue on our polyman. I have to now manually attach it to the material instance. Let's go to element 0, and then we can find our color 2. Actually, we're changing color 1, and color 1 is an RG and a B and an A. The secret to here is to go to the first frame, highlight it, copy, and then go, that's blue, so go to blue track. These shouldn't be keyframed. Go to blue track. There, you just copy and paste it in. So let's go to first frame here. This is our green track, green. Paste it in, and then go to the first track of red. Copy them all. So, like, you know, when we go back through and we do these recordings, like people come back through and add, the camera people will add in camera moves, and then we can finesse our material changes we want to. So now when I scrub, the guy changes colors. All right, so that's the quick fix there, is to store it as a value and be able to copy and paste it back in. And then we have the values. The other issue, I don't have any particle systems in here, but the other issue is to particle systems don't render, or at least cascade particle systems don't render when you scrub through. So sometimes you have to actually go and find your sequence and actually throw it in the scene and actually play it back to see your particles. So if you're doing particle effects, I think Cascade, you have to do it this way. On Niagara, I believe that Niagara can scrub through. They've designed Niagara for sequencer. So just be, as you're buying things from the marketplace, it's something to be wary of. And then, you can always spawn these characters, or sorry, spawn these particles, or be able to see that as you scrub through. All right, so save all. Okay, so to reiterate, to get this homework to work, everyone should have some sort of asset that they can work with. Maybe if you're working on an entire level, you might want to just isolate like a single asset from your level or your world or something like that. Throw it into your level that you already have, if you want to. You might have also seen that if you show your developer content, everyone has a developer folder, right? So here's the people who have committed, who have developer folders. You can also stage things in here if you're messing around with them, if you're not ready for them before you turn them into the assets folder. Everything that's part of a marketplace asset will have its own root folder. Keep it in those own root folders, right? So this might be Desert World 5, right? And so everything stays in their marketplace folders. Things that we create from scratch go into this asset folder, and we just divide it up to blueprints, maps, and materials and presets. If there's some sort of value that you don't want to, I'm trying to say, if my blueprint OSC doesn't do enough for what you want to do, or you want to alter it, you're more than welcome to alter it. You can add more URLs to it. You can add more interfaces to our interface, right? So you come in here, you can add more of these functions here to the interface. I tried to make a good random sampling of floats and ints and bools and that kind of stuff for you. I'd say the last kind of thing that I'd want to do here is show you how to pass back and forth a max patch. I'm going to go to my VPN, make sure that I'm on, all right, and my URL, my IP is ends with a .242 on this computer. On Macs, I'm going to go and add another node here. So I'm going to send it localhost, but also send it to the VPN, which is nice. And I can send this to everyone in the class. I can add a node for everyone's IP address, so I want to send it to everyone's computer. And let's go ahead and say save there. Save. If I go back to OSC, instead of sending from a local host, I can set it up to receive from you guys from all over the world. Right? So now it's not looking at localhost, it's looking at the VPN. I'm going to check and see real quick if this even works here. So yeah, it still works for me because I'm sending it localhost and over the VPN. I think it's just my VPN that I'm receiving on. I have no idea what that red hoop is. Cool. So let me go over to Macs, and everyone who has Macs installed, I'm going to unlock it, select all, and there's a thing called copy compressed. All right. I'm going to go into Slack for week 12, and I'm going to paste. Everyone can then grab this gobbledygook of text, copy, open up your Macs, and say new from clipboard. See that? Or you can hit Control-Alt-N. All right? And that'll just open up the Max patch on your computer. So now you have it, right? You don't have to save it. Like, this is the file that was sent. You can copy paste anytime. All you got to do is lock it, and then the whole UI should work for everyone here. Toggles and bangs and sliders and knobs and all that kind of stuff. Cool. So, not sure where you folks are in the process of installing Macs, but if you have it installed, it should be as easy as just saying edit, copy, or sorry, edit file, new from clipboard. You should have this, lock it in place, and then if I come back here and I hit simulate, I'm not doing anything. So somebody is remotely controlling my computer, right? So I hit record, let it go, and now it's being recorded to sequencer remotely. And this is, imagine now somebody's recording a live link face. So we're sending out live mocap. We have a virtual camera. This is how everything and how we can all work as a studio that's all together, and everyone can have their own unique tasks, and it's all building towards this project. This is the mindset I want us to kind of go towards. It'll be a work in progress for sure, but I think this really kind of it unmasks like this one final component is how do we do this all live? We have live mocap. Let's do this all with live everything else. So now everyone can control. We really can't tell if it's one person or the other. We would have to, and you guys are fighting over it, right? You're what we would do is, so for right now, we're all using these values that are the same, but we might add into our spreadsheet our own unique value that we need, right? So like, if we go into our virtual production spreadsheet, if we want to have maybe a unique value, you can add it in and you can claim it, right? So maybe the asset link, we don't really need that anymore. Maybe the name folder, you could say, oh, Grant wants to reserve, Satan 1 and Satan 2, right? And then we can just add that to the Blueprint interface, and then Grant could be in charge of driving the values for Satan 1, Satan 2, right? So we can add more, but for right now, this is enough for testing and doing for our homework so that we're all trying OSC. Again, obviously this blueprint is complicated, but it's not necessary for us to make. It's just necessary to understand that it has to be in the level for OSC to be distributed to everything else in your level. Okay? I'm going to return this to 127.0.0.1 to make sure that it works on everyone's local computer when they pull the project. All right. Confirm that it is working locally. I'm going to go back into, we'll go into this one, and we'll, I don't worry about it for right now. I just want to make sure that it's still working and it is a local host. It is. Great. So I'll save all and make sure I didn't miss any steps. No, that's pretty much it. So yeah, if you're doing any material changes, you're going to have to potentially store it as a value. But light intensity and colors changes. Like one thing I wasn't doing is you can move things around, right? You can use these scalars to scale this, right? You can make this get bigger and smaller. There's just tons of things you can think about when you look at every one of these things in your detail. Everything in the details panel could be changed in real time, right? It could be mundane or it could be pretty interesting. And just go to town, do a little bit of research on it. It really doesn't take long. Just add the interface to the class settings, and then these events are available for you to roll. Just make sure the OSC blueprint is in your level. That pretty much covers it. So the final steps would be for me to save all, go ahead and close out. Then I will commit this to the repo so everyone has it if you want to see my work. So select everything. Live show control from week 12. Hit OK. Cool. And this will be uploaded for you. And then for everyone's homework, what I'll do is I'll go through, I really wanted to go over this stuff, and I know it took a while, and I also wanted Grant to be able to speak because he's cool, and I want you guys to make a connection before the class ended. So what I'll do is I'll go through all the posts on Slack, and I will, in a thread, respond to them all. And if you guys want to come look at everyone else's homework too, you can see what everyone else is working on. We'll start with class with reviewing where everyone's at. But the homework is now to at least migrate over one asset that you're sure you want to use, throw it into a blueprint, and test to make sure that you got live show control. Don't just waste your time. Do something you think you might be able to use for class, for the final project. Like you could do things like trigger animations and trigger morph targets and all that kind of stuff. Just ping me if you have any questions. And I have some more slots for office hours on Monday. Some people are interested in, like, for instance, Amon, you're working on the vampires. You might want some custom mocap of them drinking Bloody Marys. You might want to think of some people who might want to do mocap with you. We could do that in class on next Wednesday, but also, there's lots of like stunts and actions that need to be done, and we have performers for face and body. We have one less performer for face, and and then when it comes to music and sound, again, we're just going to be working these different scenes. Make us a mixtape, find us a song. It's really not about getting into sound effects. We're not really worried about, we're not recording audio. We're not going that far. Camera operators, again, we'll alternate between these. Ryan will be assisting all 3 acts, and you'll be in charge of adding camera moves after we recorded. Get ready for stuff. And then we'll figure out who's going to be doing the performers before next week, and maybe we'll get set up before class, even though class starts at 2. Maybe we'll get the motion capture ready and ready by 1:30, or start getting it ready by 1:30, so we're not wasting more time on that. I'll just ping you guys and we'll figure it out. But for right now, let's go ahead and end, and you guys have a couple days off. Let me know if you need anything. Thanks for, I'm sure this was a super long demo. Thanks for watching and participating, and we will see you next week. All right. Anyone have any questions about the assignment or